Okay, so good afternoon. Welcome to the week 2 live interactive session of course NOC EE-28 Signals and Systems, taught by instructors Professor Hitesh Shrimali and Professor Kushal Kesha. Uh, I'll be the TA for this session, and my name is Yawar, a PhD student at IIT Kanpur. Uh, the schedule for my sessions is every Sunday, 3 p.m. to 5 p.m. Can anyone among you confirm if I'm audible?
Yes, sir, we can hear you.
Okay, fine, thank you. Okay, so let's quickly go over through the guidelines and prerequisites. If you have any query, you can ask in the chat window or you can raise your hand. Uh, Please make sure your microphones are muted when you don't intend to speak. Uh, let's make this session an interactive one. So I would appreciate the cooperation for the same. You may keep a pen and a paper handy along with the smartphone. The recording link for the session and the lecture notes will be shared in the due course of time by the NPTEL course team. Okay, so coming to the prerequisites. Prerequisites include the last week's lectures that covered the following topics: types of signals and transformations, digitization, sampling, digital systems, waves. I'm sure you would have gone through these week lectures, and I'm also quite hopeful that you would have already attempted the assignment too. Okay, so let's first briefly recap continuous and discrete time signals before attempting a sample problem on the same. So a continuous time signal has values for all points in time in some interval, which can possibly be an infinite interval, while as a discrete signal has values only for discrete points in time. So this is how continuous time signal differs from a discrete time signals, wherein this continuous time signal has values for all points in time. That is not the case with a discrete time signals. Moreover, a discrete time signal that is usually written as x of n, the n is an integer. Okay, so it will have values corresponding to the integral values of n. For example, for n equals to 0, n equals to 1, n equals to 2, and so on. And as was the case with this continuous time signal, this interval can very well be infinite. Now let's go through the definition of periodic signals. So a continuous time signal is periodic if and only if there exists a t0 that is greater than 0 such that this equation is satisfied for all t. Okay, this t0 is the period of x of t, right? Now, a signal can have many t naughts, right? And the smallest one would be the fundamental time period of that signal. A discrete time signal is periodic. This definition is similar to how we define the periodicity in continuous time signal. A discrete time signal is periodic if and only if there exists an integer. Note, we did not use this condition, right? We said that in continuous time signals, a signal is said to be periodic if there exists a t naught that is greater than 0. We did not impose any condition on t naught, right? However, in discrete time signals, since this n is an integer, so we impose a condition that this period n naught should also be an integer that is greater than 0, such that this equation is satisfied. N0 is the period of x of n. Yeah, we went through that. And this smallest t naught or this N naught is the fundamental period of the periodic signal. With that, we have our first sample problem, and that is to determine the period of sine of 1 plus pi n by 6. Uh, uh, Attempt this problem and let me know the answer in the chat. I would wait for a minute and a half. Is this signal a continuous time signal or a discrete one?
So by looking at the symbols, sorry, it seems discrete.
Yes, it is a discrete. So is there any condition on the period of this signal?
It should be an integer.
Yes, it should be an integer. 12. The answer is 12, the correct answer. So let's see how that comes about. Okay, so the given signal was x of n equal to sine of 1 plus pi n by 6, right? And we know for periodicity, the condition that should be satisfied is x of n plus n0 should be equal to x of n, right? And we'll call this n naught, the period of x of n, right? And note this n naught would be a non-zero integer. Now, x of n plus n naught is x of n, right? I'm talking about this. X of n plus n naught is x of n, and my x of n is given by this function, right? So I'll substitute n by n plus n naught and get this left hand side. So it is sine of 1 plus pi by 6 would be n plus n0, right? And my right hand side is x of n, and x of n is this sine of 1 plus pi n by 6. Okay, now this gives me sine of 1 plus pi n by 6 plus pi n0 by 6 is equal to sine of 1 plus pi n by 6, right? And then this above equality is satisfied when this, wait, what happened? Okay, so the above equality is satisfied when this pi and naught by 6 is an integral multiple of 2 pi, right? That is true for all sinusoidal signals, and that is true for this case as well. So we'll write above equality is satisfied when this, okay, pi and naught by 6 is some k times 2 pi, right? It would be, we are not interested in zero, otherwise zero would also be a solution, right? We are interested in finding a non-zero integer. So we'll take the smallest case, right? 2 pi. So if pi and naught by 6 is 2 pi, this gives n naught as 12, which Neeraj pointed out in the chat as well, right? So that is how we compute the period of the signal. If it's not mentioned in the question, usually by period we mean the fundamental period, right? For example, we could also have taken k equal to 2, right? And 4 pi would also have been the period, and corresponding to 4 pi, the answer that we would have got is 24 seconds, right? Was 24 seconds in the options? Okay, no, 24 seconds was not in the options, but the 12 second is a fundamental period, right? Because it is the smallest period of the signal. Is this clear?
Yes, sir.
Okay, so let's move on to the signal transformations. We have some transformation operations that we can perform on signals. I'm sure you would have gone through them, but I would still briefly recap them and revise them. So let's see the amplitude scaling first. Okay, so in amplitude scaling, we simply scale the amplitude of the signal by the constant A, right? So if this was the given signal and we were interested in scaling the, we suppose this was x of t, okay, this was x of t, and we had to obtain this 2 times x of t. This is an amplitude scaling transformation. So we just multiply this signal by 2 and obtain this. I hope it is clear. I'll move forward. And likewise, we have this amplitude scaling operation for a discrete signal as well. Okay, so the scaled signal ax of n is this x of n signal multiplied by this constant a. Suppose this constant was 2. So in this case, we would get this signal 2 times x of n from this. Let's move on to the time scaling one. Okay, so a signal x of t is scaled in time by multiplying the time variable by a positive constant b to produce x of bt. A positive factor of b, it either expands or compresses depending upon this value of this b. Okay, so let me zoom it. If this was our signal and we were interested in obtaining x of 2t, x of 2t would mean that this factor b is greater than 1. So that would mean that we are interested in compressing a signal. Okay, so if you are getting confused by this expansion and compression operation, what you can have is a quick sanity check. For example, this original signal, it was, see, it was 0 at this 2, right? And earlier it was x of t. So it was at x of 2, it was 0, right? Now we have x of 2t. Okay, x of 2t. And we know that x of 2 would be 0. So this means that now that 0 would occur at this, right? T equal to 1. So I hope this compression transformation is clear. And similar is the case with this expansion operation, right? So yeah, I hope this is clear. You can go through this. This is analogous of this compression operation. Now, a likewise analogous scenario can be seen in this discrete time signals where x of n, if this is given by this sequence, our x of 2n would be given by this signal. Okay, now this x of 2n is this b greater than 1, right? And for that case, we know that the signal compresses, right? So our intermediate samples are lost. Okay, so earlier we had, how should I explain this? X of 2n, x of 3n. Okay, so suppose we had this signal, right? At x of 3, we had some value. Now for x of 2n, what would that, will that value occur in the sequence x of 2n? Someone unmute and just speak up. Was the question clear or should I repeat it?
So please repeat the question, sir.
Okay, so what I'm saying is the original sequence x of n had this, right? Had some value corresponding to this n equal to 3 sample, right?
Yes, sir. Yes, sir.
Okay, and uh, the point that I'm trying to make is that these samples, for example, this sample will get lost. I mean, this won't occur in the resulting signal. The reason being, see, what we effectively are doing is that for x of 2t, what we did was we just divided this by 2, right? Throughout to obtain this, right?
Yes, sir. Yes, sir.
And if we would do the same operation on this x of 2n, this 3 would be 3 by 2. Okay, and 3 by 2 is not an integer, right? And
Yes.
since it is not an integer, this won't occur in the resulting sequence. Is
Okay.
this point clear?
Yes.
Okay. Can you point out any other sample that will be missing or that gets lost in this x of 2n apart from this?
So I
Okay.
think all the odd numbers
All the odd
you.
numbers.
Yes, sir.
This one, this one, this one, and this one, right?
Yes, sir.
We'll be losing these samples. And we are left with 1, 2, 3, 4, 5 samples. And these are these 5 samples. Okay.
Okay, sir.
Similarly, for the case of this expansion, so this is called downsampling. Okay, when this factor b is greater than 1, we call that this signal is downsampled. Because note, earlier we had uh, 1 2 3 4 5 6 7 8 9 samples, right? And after performing this operation we have 1 2 3 4 5. We have less number of samples than the original sequence, so that's why this operation is called downsampling. Okay, now the other case, when this b is between 0 and 1. Okay, now when that is the case, what should happen is, like, what we did in this case was we divided them by 2, right? And then looked out for the integer values and made a statement that only those samples would exist. However, in this case, since this is x of n divided by 2, you would have to look for these samples. Do you agree? So corresponding to 2, we get this sample. Corresponding to 1, we get this sample. 0 is 0, minus 1 is minus 2, minus 2 becomes minus 4. Is this clear? Or if anyone has any doubt, he can either write in the chat or unmute and ask that out. Okay, so the intermediate samples must be synthesized. Fine. For example, now earlier the sequence existed for -2, -1, 0, 1, 2, right? We had some value of x of n corresponding to these samples. However, in the sequence x of n divided by 2, we have samples, we have, I mean, values corresponding to sequences -4. I would leave this blank. -2. Do you agree with me? I mean, I don't have any information about this, right? Neither I have this, neither I have this, nor I have this. So these samples must be synthesized, and for now we'll set them to 0. I mean, uh, when we'll move ahead in the course, we'll uh, see how these samples can be interpolated. But for now, we can assume them to be 0. Okay, so now if I would give you some x of n sequence, would you be able to obtain uh, upsampled and a downsampled version of the same?
Yes, sir. I think we
Okay,
can.
fine. So then comes this time reversal, which is actually a special case of this time scaling, right? Why is this special case? I'm saying this time reversal is a special case of this time scaling.
Sir, here the multiplying factor is
Yeah,
-1.
b is minus 1, right? So when we replace t by minus t, we get a time reverse signal, right? So suppose, wait, we had some value at this t naught. Where would that value occur in this scale? Would it be on this side or this side? It's clear from the graph as well, right? It would be on this side because earlier we had x of t, right? Now we are interested in finding x of minus t, right? Let us suppose we had some value. Say this is A. Okay. So I'm saying this x of t naught is A. Okay. Now for x of minus t would be A. Okay. Is my question
minus
clear? Yeah, minus t naught. So it would occur on this side, right? It's
okay,
like
sir.
a reflection along y-axis. Okay. So now for discrete time signals, similarly, we replace n by minus n and obtain the time reverse signal. If this part is clear, this should also be clear. Now, there is this time shift operation, right? For a continuous time signal x of t and a time t1 that is a positive quantity. I'll assume this t1 is a positive quantity. Now, if we replace this t by this t minus t1, we get a delayed signal x of t minus t1. Okay, so if the signal is x of t and I'm interested in obtaining a signal x of t minus t1, I would get a delayed signal. Is this part clear why this is a delayed signal? I mean, we are replacing t by minus t1. So should it have occurred? I mean, should this be x of t minus t1 or is it right what I've shown? Saying if my signal is x of t, let me make one. Okay, suppose I have a signal x of t, right? This is that signal. And I need the signal x of t minus say 1, right? So should I shift the signal by 1 unit to the right or shift the signal 1 unit to the left?
So to the right.
To the right. And why is that the case?
Sir, argument the value of, if we put the value of argument is uh, and uh, and according to the last graph we put the value of y, then it
Yeah.
comes up to be shifted.
So what you are saying is, see, we had, suppose this was 0, this was 1, 2, and this was 1, right? Now, x of t minus 1. So we know the signal is 0 at t equal to 0, right? 0 at t equal to 0 and it's 0 at t equal to 2. So it is 0, right? This is our signal. So no matter the time shifts, the function would still have the same value corresponding to that argument. Okay, so at x of 0, wait, so now this point would shift 1 unit to the right because at t equal to 1, this t minus 1 is 0, right?
Yes.
And similarly, this point would shift 1 unit to the right because t equal to at t equal to 2, this t minus 1 at this t equal to 2, this t minus 1 is 1. I hope that is clear. I'll move forward. So if this time shifting is clear, we can, okay, the analogous case is for the discrete time signals x of n. X of n minus n1 would be a delayed signal, and x of n plus n1 is an advanced signal, right? And as we uh, gave the argument for the continuous time signal, we can give an analogous argument for discrete time signals as well. Now in problems, you would encounter the combination of these operations, okay, where time scaling, shifting, and reversal, they all will be combined. Okay, for example, if this is the case, right, x of 2 times t minus 1. So we can, I mean, move in either order, right? Since we have multiple operations, there is no such a restriction on the order in which you will be performing the operations, right? There is no, I would say, I mean, that is not prohibited, right? You can follow any order. But this one is simpler one, right? So if we scale first and then compress, right? Compression because this factor is greater than 1, right? V is greater than 1. So that is why the signal would be compressed, right? And yeah, fine. And shift because, okay, would this be a right shift or a left shift?
So right shift.
Yeah, it would be a right shift. So let's perform scaling operation first and then shift it. If we scale it, I hope this is clear, right? This would be x of 2t. And then if we shift this signal to 1 unit by right, you would obtain this signal. Again, a quick check. You can put this argument equal to 0, right? And it should be, see, if you put this to 0, what would you get? You would get t equal to 1, right?
Yes, sir.
And notice earlier what was at t equal to 0. Why is it not working? Okay. N- Earlier, the value of this x of t at t equal to 0 is same as the value of the signal at this t equal to 1, right? 2 for both. I hope this is clear. So the other way around, if we shift it first and then scale. So the caution that needs to be exercised if we shift it first is that, uh, see, one way to shift would have been that given a signal x of t, I would shift it by, uh, see, I would perform this. There is shift by 1 unit, right? So the wrong way of doing this would be to shift it by 1 unit, followed by the scaling operation, right? Scaling by 2. Why this is wrong is because in shifting, uh, I mean, The this is wrong because see the right way of doing it is this and stop working. Okay, x of 2t minus 1 can be written as x of 2t minus 2. So this is the catch. Okay, so if you will exercise this question, then you are fine with either of these two approaches. You will shift the signal by 2 units and then scale the signal by 2 units. Okay.
Okay.
Okay. If this is my signal, okay, wait, let me ask you a question. Suppose I have this x of 2t, right? And I give you a signal x of 2t minus 2. Okay. You forget this. Focus here. And I ask you, I want to scale this signal first and then shift. Okay.
Okay, sir.
So what would be the scaling factor? Okay. I'm asking you to scale it first and then shift. I want this order to be followed. What would be the scaling factor?
So 2,
2. And what would be the shift?
so 2 to the right.
2 to the right. But this is wrong. Can you think over this? Why is that the case?
So if we write it in the form of x of 2 bracket t minus 1,
Yeah.
then we have to follow the Bodmas rule. First, we have to solve the brackets. I have no proper answer to this, sir. Please explain.
So if you are given a signal in this form, x of 2t minus 2, you would write that first in this form, right? I mean, take out a factor if it's common, right? For example, even if I had suppose 3t minus 5, what would you do? You take out this 3 factor, right? This doesn't mean that you are first, yeah, this does not mean the wrong way of doing it would be to scale this signal by 3 and then follow this by a shift by 5. The correct way of doing it would be to take out this 3 factor common first. Okay, x of 3 t minus 5 by 3. Okay, and then you will scale this signal by 3 and then this would be the shift.
Okay, sir.
Is this clear now?
Yes, sir.
So
This is the rule
likewise
we have
was
to
the,
follow.
yeah, you need to just exercise a caution in this case. Otherwise this is simple. Combining them is simple. That was what I wanted you all to point out. And yeah, let's move on to the sample problem 2. If y of t is a signal with unit magnitude between this and it is 0 otherwise, then this signal will be which of the following options? Attempt this question and let me know in the chat. Option one is this unity between this. Yeah, this is the correct option. So I'll quickly go over through the solution. So see, let me add a page first. Is it would be this would white. Now we have a signal. The signal was y of t, right? I don't have that. Yeah, signal was y of t and it was a unit magnitude between these. Okay. So y of t is 1. Right? This is our y of t, and we are interested in finding y of 2t, right? Was it y of 2t or y of t by 2? So since this is a time scaling operation, the only thing that would change is these limits, right? And the behavior of the signal is same throughout, so it would remain like this. So to obtain these limits, see, I need signal y of t by 2, right? So I would multiply these by 2. 40 minus 40 with a unit magnitude. And option A is the right one because that is what we answered it, right? It is unity between this t equal to modulus of t less or equal to 40. Wait, yeah, modulus of t less or equal to 40, and it is 0 otherwise. Is 0 is 0. Let's move on to the next question. The period of this discrete time signal cos of 2n by pi is, okay, if x of t is a signal with unit magnitude between and 0 otherwise, then this would be, uh, is that an assignment problem or are you asking out of curiosity? If it is assignment problem, then yeah, if it's assignment problem, I cannot discuss that. However, see, similar to this problem, what is y of t by zero point 0.5? What is y of t by zero point 0.5? I'm asking you, Suraj. I want you to write it in the form of y of bt. What would be b? If you cannot unmute yourself, you can write in the chat.
Sir, I think I am not able to answer it now because I am confused of that point.
Okay, see, y of t by zero point 0.5 is y of t divided by half. Is this part fine?
Yes, sir.
Can you now do the question? It is the exact opposite of the one which we did, right? In this case, it was expansion, and these slides will also be shared, and you can go over through the recap once more, and I'm sure you would be able to solve this question. So if this is an expansion
Yeah, okay, sir.
operation, if this is an expansion operation, is this an expansion operation first? If our original signal was this, now this question is to everyone. This was our earlier signal, and this is the signal like y of t by 2. Only, okay, the answer, yeah, I'm not sure. I mean, but I would suggest we do not discuss the assignment questions in this session. We can discuss any questions, whatever confusions you have, but apart from the questions that are there in the assignment. Okay, you can figure it out. Okay, so the question that I was posing was, if this is our original signal and this is the signal that we, I mean, obtained by using this operation y of t by 2. So is this expansion or compression?
Sir, expansion.
Yeah, this is expansion because this can be written as 0.5 t, and since b is less than 1 and greater than 0, so this is expansion. And what would this operation be if b is greater than 1? This case,
Compression.
compression, right? I'm sure you would be able to figure it out. Let me remove this part. Okay, let's move on to the next question. The period of this signal, discrete time signal, cos of 2n by pi. What is the period of this signal? Attempt this question and let me know in the chat. All of you attempt this one. It is a discrete time signal, right? Aperiodic. Correct. I would still wait for a minute for the other two guys to solve this question. The answer is aperiodic. Neeraj is right. Okay, I guess that is sufficient time, and let's see how this signal is aperiodic. Question number 3. The period of this discrete time signal cos of 2n by pi. X of n is cos of 2n by pi. Yeah. Now if this is the signal, then I can write x of n plus n naught. I'm using the condition of periodicity, right? If this is a periodic signal, then this condition should be satisfied. X of n plus n naught is x of n, x of 2n by pi. Sir, periodic. I'm glad Suraj also came to the same conclusion. 2n naught by pi is cos. Oh my, this is cos. Okay, cos of 2n by pi. Fine. So, like we proceeded in an earlier question, we'll write that this argument then should be an integral multiple of 2 pi, right? So we'll take k equal to 1 value with an intention of finding the fundamental period. This 2 and 2 goes, sorry, this 2 and 2 goes, I'm taking k equal to 1. So n naught is pi square, right? Is pi
Yeah.
square an integer?
No, sir.
Because we had a discussion before that this n naught has to be integer, right? And in fact, this n has to be integer. This pi square is not an integer, right? So that is why we conclude that x of n is a periodic. Why is it happening? Because n naught that is equal to pi square is not an integer, right? Let's move on to the next question. Question number 4. If y of n is a signal which is 0 for n greater than minus 2 and n less than 1, let me write this interval for you. Meanwhile, you can attempt this question, right? Start attempting this question. Write this y of n is 0 for this interval. So the only thing that we know about this y of n is that it is 0 in this interval. What will be the values of n for which it is 0? I hope you all are attempting, right? This is y of n. The only information that we have about y of n is that it is 0 in this interval. Okay, so you are saying y of n plus 1, y of n plus, we'll see if that is the right answer. Okay, so meanwhile, help me out. Y of n is 0 in this interval. So what are the values of n for which it is 0? Remember, n is integer.
Yes. -1 and 0.
Yeah, n equal to -1, 0, right?
Yes, sir.
This one and this one. It is 0 for these values of n.
Sir, -1, sir. You have marked +1.
Oh, sorry. -1 and 0. This is question 4, right? Question 4. So, and what is the signal that we need? We need a signal. Let me write this out. That is 0 for n greater than -3 and n less than 2. If I combine these two, this is the interval, right? Wait, sorry. Right? This is the interval for which this x of n would be 0. So the values of n for which this signal would be 0 are, suppose I call this signal, no, I should not use
Sir,
g
-2
of
and
n.
-1.
Yeah, this is 0 for -2 and -1, right? And my original signal y of n was 0 for these two values of n. Y of n, this is my required signal, okay? And our y of n was 0 for -1, 0. Let me copy this one, save my time. Suppose I now -2, -1, right? So it is not g of n is 0 for -2, -1, okay? So this to this is clearly, is this a delay operation?
No, sir. The signal is being advanced.
Yeah, signal is being advanced. So this is clearly this g of n is y of, and this is getting advanced by 1 unit, right? So
Yes, sir.
y of n plus 1. Yeah, that is the correct answer. Now the next question. Is this question clear though? For the other two people, Suraj and Om Kohli.
Yes, sir.
Okay, I'll move to the next one. X of t is a sine of pi t and y of t is b cos of pi t. And we are interested in finding a relation between x of t and y of t. So this basically, I mean, you need trigonometry to solve this question. Attempt this question. So the good approach would be to first find these signals, x of t plus 0.5 and x of t minus 0.5, right? Because that is what is occurring in the options. And then try to establish a relation of y of t with that. I guess I'll start solving it myself as well. So this is question number 5. So let me first evaluate x of t plus 0.5 and x of t minus 0.5. X of t plus 0.5. Our x of t was this, right? Let me even write this as well. Can I write this? X of t was this a sine of pi t. And this y of t is b cos of pi t. I hope you all are solving it as well. So what would be x of t plus 0.5? It would be a sine of, just simply replace this t by t plus 0.5. So this would be pi t plus, right? It would
Yeah.
be pi times t plus pi times 0.5, and that is what I have written. So this would be a sine of pi t plus pi by 2. Similarly, this is a sine of pi t minus pi by 2. Now, do you guys remember this one? Sine of theta plus minus pi by 2. What is this equal to? Does anyone remember this? I would suggest you all to revise your trigonometry fundamentals. because we'll be frequently using those throughout this course. So this sine of theta plus minus pi by 2 is plus minus cos theta. You can also do one thing, you can plot this one on this. What should I say? This desmos. Are you aware of desmos?
No,
Wait,
sir.
No, sir.
wait. I'll send a link in the chat and you can meanwhile play with that. Okay, I'm talking about this one. So head over to there and do one thing. Plot this sine of, do one thing, use x here. Sine of x plus pi by 2. For pi, write pi. It would automatically recognize that that is pi. Actually, I'm short of time. Otherwise, I would have done that myself. So what you can do is, if you need any sort of assistance, you can mail me as well. Okay, you will anyway get access to these slides. I'll have the plot of this sine of x plus pi by 2 and cos of theta in Desmos. Uh, I'll attach that plot in these slides. Okay, you can have a look there as well. So now, given that you know this, actually this is not that difficult to prove. What we can say about this? Can we make any comment? This is cos of pi t, right? Is it? A, this is minus a cos of pi t. See, if doing it graphically is taking time, does anyone among you remember this formula?
Yes, sir. Sine A plus B.
What is sine of a plus b? Let's do for positive case. Negative you can do yourself. Sine of
Sir,
a plus b. What is sine of a plus b?
sine A cos B plus sine cos A sine B.
Sine a cos b plus cos a sine
Sine
b.
B.
Right. Can I use that here? Now, a I'll take theta, b is pi by 2. Cos of pi by 2, what is that?
O, O
That
0,
is
sir.
0, right? So this term would cancel. We are left with this term, right?
Okay, sir.
What is sine of pi by 2? Because b is here,
1.
right? And this is a is nothing but theta. So this is cos of theta. That is why for this positive case, I'm getting positive cos theta. Now you can see yourself why sine of theta minus pi by 2 is minus cos theta. Is that clear?
Yes, sir.
Okay. So now coming back to the question. Now a cos pi by t, right? I wrote this as a cos of pi by t and this as minus a cos of pi by t using this. Fine. Is that clear?
Yes, sir. Yes, sir.
Okay, why I'm getting ruled narrow? Shit. Okay, we have page. So now see this x of t plus zero point 0.5. What is that equal to? A cos of pi t, right?
Yes, sir.
This is equal to a cos pi by t, pi t. So this x of t plus zero point 0.5 would be equal to. Now I need to establish a relation between this x of t and y of t, right? And if you'll see, you have a b coefficient with cos for y of t, right? So I'll try to express my cos in terms of this function as well, right? In our case, we are having this a, but what we can do is we can divide by b and then multiply by b, right? And now this one looks familiar. This one, b cos pi t,
YT.
that is yt, yeah. So this x of t plus zero point 0.5 is this a by b yt. Is this clear?
Yes, sir.
So that is what effectively we were asked in the question. So I guess which option is correct? B, I guess, right? Yeah, is it?
Yes, sir. It seems so.
No, wait, yeah. This B one is correct because we can
We have to invert the factor
alternatively,
of b.
yeah, we can write y of t as b by a times this
X of t plus 0.5.
x of t plus zero point 0.5. One and the same thing, and that would give us the correct option. Now let's move on to the next one. For this figure, x of t and y of t, how are they related?
I think they are the shifted version of the each other.
So you are saying that they are the shifted versions. Let me write what you are trying to say. You're saying that given this x of t looks y of t, what is y of t?
X t
X of
minus 2.
t minus 2.
Yes, sir. Sir, I think there is a scaling, sir, too, sir. Operation. I
You
missed that.
want this,
Yes, sir.
right? And that is what the answer is, right? So which option is correct? 2 times x of t minus 2. I guess this one,
Last one.
right? So we'll move on to the next one. Was this clear for other people as well? I hope this was pretty straightforward.
Yes, sir.
Okay. Now for this figure, x of t and y of t, you need to establish a relation between these two. Think carefully on this one. There is this time scaling, right? It
Yes.
existed for 2 units in x of t and it's existing for 4 units in y of t.
Yes, sir. Then first option, sir.
X of t by 2. Will that give us the answer?
Yes. For expansion, b should be less than 1, sir. 1 by 2
For
gives.
expansion, b should be less than 1. So you are saying that y of t should be equal to x of, right?
Yes.
But see, in expansion, I told you that there is a quick sanity check, right? If the original signal was 0, See, it was 0 at this 3 and this one, right?
Okay, sir.
So what are the corresponding values of y?
Sir, y of 0 and y of 4.
No, no, no. See, that is you are telling me on the basis of this graph, right?
Yes, sir.
I'm telling you to perform a sanity check based on the answer that you gave, right? You told me that y of t is x of 0.5 t, right? So if this argument, if this, see, I'll reframe this. Maybe you will understand that way better. X of t was 0 for t equal to 1 and 3. Agreed? And x
Yes,
of
sir.
t was equal to 1 for t equal to
2.
t equal to 2. Now, these arguments, the whole arguments, they will remain same, right? For this,
Yes, sir.
let's find out. If that is the case, then see, then this value, this 3, the value corresponding to this 3 would be reached in this x of 0.5 t at t equal to
6.
at t equal to 6, right?
Yes.
So, but in the answer, that is not the case, right?
Yes.
That is getting reached at t equal to 4,
Yes, sir.
right? It
I got
turns out it is first a shifting operation followed by a scaling operation, right? See, the hint was you had 0, right? The only way you would obtain a 0 is by means of time shifting. There is no way you can get to 0 by time scaling, right? For example, if I perform any operation on this signal, right?
Okay,
Suppose I
sir.
use x of bt. There is no way this point would have moved to this. Do you agree? Can you see that or should I explain why is that the case?
सर एक बार proof दे दीजिए सर.
हाँ, proof दे देता हूँ. See, the thing is, suppose I use x of 10t. Why is this not working? X of 10t, for example. Fine. What is x of 10t? I mean, use that here. If this is x of t, what is x of 10t?
X of 20.
The reason I used this greater than 1 was because I somehow want this 1 to go towards 0, right? I
Oh,
can make this move towards left, but I cannot make this reach 0. Theoretically, it will reach 0 only for this x of infinity t, right? And that would not make sense. Because what, see, suppose you have this x of 2t, right? Let me draw a signal for this x of 2t that would perhaps clear that out. What would be x of 2t? Help me out. This value would be 0.5. Agreed?
okay, sir.
What you did was you divided this by 2, nothing else, right? So this is my x of 2t. Similarly, this x of 10t would be dividing this by a 10,
Okay, sir.
right? Dividing this by 10 would make this zero point 0.1, right? And this as 0.3.
Okay, sir.
Even if you move on to a very greater number, for example, say x of 1000t, still there would be some finite number, right? Because 1 divided by 1000, what is that? 1 divided by 1000 is 1 milli, 10 is per minus 3. That is not 0.
Yes. Yes, sir.
So I hope this makes sense, right?
Yes, sir, I'm
Using
getting.
time scaling, you won't be able to reach that operation. So the only way we can do that is through time shifting, right?
Okay, sir.
So first, what we'll do is we'll perform time shifting. Right. Yeah. So this is how we'll perform time shifting. Question number 7. So this is original signal x of t. So which shifting should I perform? Should I delay it or advance?
Advance, sir.
Advance. So I should do x of t plus 1, right?
Okay, sir.
When I'll do that, I'll get this signal. What is the signal y of t though? Let me make y of t now. This is y of t, right? Yeah. So what should this y of t be equal to? See, this point won't get scaled, right? I mean, this would be fixed because 0 divided by something or multiplied by something would remain. So this would be like hinged.
Okay, sir.
And this 2, we can expand this, right?
Yes.
And we can expand this point as well to this 2. So I hope this is clear that the operation is. Would anybody like to guess the answer? What should be this factor? Because
Two,
you
sir.
want to expand. This factor should be
Two.
2 would compress the signal, right?
Oh, sir. 1/2.
1 by 2. So that is how the answer comes, right? Y of t is x of t by 2 plus 1. Fine. So which option is correct? Option C. So that is this question 7. Now question 8. Now this is a similar question to the previous question, and I hope all of you would be able to get to the answer. Attempt this question and let me know the answer in a minute or so. Again, notice 0. The only way you can achieve this is through time shifting. Okay, so Neeraj says it is 3 times x of 3t plus 1. 3 times x of 3t plus 1. Does anyone else want to attempt? Or do you agree with the answer that Neeraj gave? Yeah, as per Neeraj, this is the correct answer, right? 3, everyone I hope can make sense of because this amplitude is scaled by 3. Okay, Suraj also agrees with you. And also this compression operation is there, right? The signal is in fact compressed by a factor of 3, right? Okay, so all of you agree with Neeraj. So let me then quickly go over through the steps. Shouldn't take much time since you agree. So you say that this is correct. This was x of t and this was t. So which operation should we perform first on the signal? We should advance it, right? So we'll advance this signal by 1 unit. X of t plus 1. That would give us the following signal. Then we'll write this y of t. What is y of t? Y of t is so clearly uh, is clear that y of t is 3 times the amplitude scaling factor, right? Because it was 1, we scaled it to 3, x of 3t plus 1. Is it clear? 3 times x of 3t plus 1. Okay, the next question. How are x of n and y of n related?
Sir, third option, sir.
Third option. That is the correct answer. Can you uh, explain how you came about to that answer? That is
So
correct
there,
answer. Hmm.
so there are some loss of sample points, sir. So which
Agreed.
indicates that there is scaling.
Agreed.
So then we try to match the value. The value of yn plus 1 at 1 is equal to x value of x at 3n.
Fine. So if we would perform this scaling operation, the value corresponding to this 1 would now exist at some 1 by 3, which is not an integer, right? So hence this sample would be lost. We'll be left with this sample only because 3 by 3, why is it not working? See, 3 by 3 is 1, which is an integer, right? So hence corresponding to this n equal to 1 will have value. Okay. Okay, so this one is pretty straightforward. Me quickly make a solution so that if some of you would want to refer to this later on, you can refer to it. So we have this signal x of n. The values are 1, 2, and 3. My y of n is this signal, right? This is x of 3n. 1 by 3 is not an integer. So that sample is lost. So let's move on to our last question. Before the last question, let's try to understand this. What can you comment upon this sum of two periodic signals? Why is it not periodic always? See, we can either give a proof to a statement or give a counter example, right? To disprove that. And I'm saying that I'll provide a counter example to disprove that. So does this seem obvious that two periodic signals should not be periodic? I mean, the case when it won't be periodic,
No, sir. It seems like they should be periodic.
this should be periodic. Okay, then let's have a look at one of the cases. So the example is that this f1 of t is sine of 2t. Okay, and this f2 of t is sine of 2 pi t. Okay, in general, what is the period of this signal sine of at?
Sir, 2 pi.
Is it 2 pi? It is 2 pi for sine of t, right? I'm writing this sine of at. See, this is your omega, right? Here this omega is A, right? And 2 pi by, why is it not working? 2 pi by omega is what we call this time period, right? Omega or frequency, whatever you call it. Okay, so frequency here is A and time period is 2 pi divided by frequency. So what would be the period of sine of 80?
2 pi by a.
2 pi by A. Okay, let me. Okay, so I have these signals f1 of t and f2 of t. What is f1 of t? Sine of 2t. What is the time period of this? Let me denote this by t1. What is the time period of this?
So 2 pi by, so pi.
It's pi, right? Similarly, the time period of this signal, sine of 2 pi t. What is the time period of this signal?
Sir, 1.
Because 2 pi by 2 pi is 1, right? So t1 is 1. Sorry, I should write it t2. Now, so how do we usually find these time periods of sum of two signals? Right? Suppose, see what I'm saying is, suppose my one signal has a time period of 2 seconds, okay? And the other signal has a time period of 3 seconds. What is the time period of the signal that is obtained by summing these two signals? It is straightforward. What
LCM.
is this? LCM,
LCM.
right? And what would be the LCM be? LCM would
6.
be 6. And LCM is nothing but finding the lowest common multiple, right? In this case, it would be 2 times 3, 3 times 2, that is 6, right?
Yes, sir.
So LCM is 6. So what I did here was I'm trying to make a general argument for my case, okay? So 2 times K1 times 3 times K2. My problem was to find lowest values of these K1 and K2, right?
Okay, sir.
And in this case, the values that I obtained was 3 and 2,
Yes.
right? And they were integers, right?
Yes, sir.
3 and 2 were integers. In other words, I can say that this, in other words, I mean this K1 by K2 should be 3 by 2, and that is a rational number, right?
Okay, sir.
So similarly, the problem of finding, see, if there exists a time period for this signal, suppose we have a signal f of t. Now come back to our case, right? This case, f1 of t plus f2 of t, right? What would be the time period of the signal would be to find, I mean, lowest common multiple, right? Suppose uh, here it's pi. I would write, let me first write t1 so that you don't get confused. So t1 times k1 is t2 times
K2.
k2, right?
Yes, sir.
And Now let me substitute back. So this pi times k1 is 1 times k2. K1 over k2 is pi. So what can you comment upon? What can you comment on this? The ratio of k1 by k2.
Sir, irrational number, sir.
It is an irrational number. Can I write this pi as 22 by 7?
Sir, it is approximation, sir.
It is an approximation, right? Pi is not equal to 22 by 7. That is fine. So it is an irrational number, right?
Yes, sir.
So that is why we say that we are not able to find these lowest integer values of k1 by k2 such that k1 by k2 is a this uh, rational number, right? Let me write this statement. So what I'll write is there does not exist any such. We are interested in non-zero time periods, right? There does not exist any non-zero integers uh, right, and hence this f of t is periodic. Uh, Now let's look at the graphical picture of the same. Okay, this was our sine of 2t, and this is how sine of 2 pi t looks. I have used Desmos to plot them that I
Okay, sir.
was referring to a few moments before. So here the period was pi. Let's see if that is indeed the case. Can see the signal starts from here, and then I mean after one time period, the value corresponding on the time scale is pi units, right? So
Yes,
time
sir.
t equal to pi is indeed the time period of sine of 2t. Similarly, t equal to 1 is the time period of sine of 2 pi t, which we had, uh, obtained, right, using that 2 pi by b formula. So let's look at how this f of t looks. That is sum of this f1t and f2t. Stare at this function f of t. Does this look periodic?
No, sir.
Right, even if one would say that it does look kind of, but if you'll see carefully, even the values don't match at any point almost, right?
Yes, sir.
So this is not periodic. Fine. So
Yes.
this is how this function was constructed. So this red one is this one.
Sine 2t.
Yeah. And sine of 2 pi t is this green one. And that is how, and if you add these two, you get this.
Okay, sir.
Okay, now the last question for today. Y of t is equals to a1 cos of omega 1 t plus a2 cos of omega 2t. It is periodic only when you'll need to find, this which of the following relation holds good if y of t is periodic. Just work it out and let me know.
Sir, first option, sir. W2 by W1 is a rational number.
W2 by W1 is a rational number. Correct answer. Let me just go over why that is the case and then we'll wind up. So y of t is periodic when this see what is t1. Suppose this signal is y1, this signal is y2, and the time corresponding time periods are t1 and t2. Okay, if that is the case, then what is t1? T1 would be 2 pi by omega 1. Similarly, T2 would be 2 pi by omega 2. Now, uh, K1 times T1 equal to K2 times T2. So this T1 by T2, uh, or say T2 by T1 should be rational, right? But what is T2 by T1, or I should say T1 by T2? T1 by T2 is omega 2 by omega 1.
Yes, sir.
That should be rational. So yeah, this was the last question, and with that, I'm done. Do you have any questions with regards to today's tutorial session? By the way, these were the slides from which I had taken, borrowed one or two slides for today's tutorial session. Do you have any question or doubt from any part of today's tutorial session?
Sir, for doing finding the result for after scaling and shifting operation,
Mm-hmm.
uh, in the beginning of the lecture, there was a rule given by you that we have to express the mathematical function in terms of that in the
Wait,
form of
I'll.
the brackets. We took out all the common factors.
Yeah, yeah, yeah. You mean to say, this one, right?
Yes,
This
sir,
is
we have
where,
to
yeah.
get in this form, then we'll get the correct results.
Yeah,
Otherwise,
if you don't follow, see, you can anytime you can perform that sanity check, right? You know what are the values of t for which x of t uh, is equal to, I mean, you know that x of t is 0 for t equal to -1, right? So no matter what this function of t is inside the argument of x, if this 2t is equal to -1, at that t, the function should evaluate to, it should evaluate to 0, right? Do you agree?
sir, I lost track. Sir,
Okay,
please,
let me
repeat it.
repeat it again. So I'm saying You know that x of t is 0 when t is minus 1. So now if you are given some signal x of 2t and you need to see if this is indeed the case. I'm taking a 2t example that is much simplified version. It can be some complicated function of t. A quick and a basic sanity check would be to see if when this argument is minus 1, right? Does this evaluate to 0? Right. So in fact, it is the point at which it goes to 0. So I would do this x of I need to put this to I need to put this to minus 1, right? This argument to minus 1. The value should be going to 0.
Okay,
So
sir.
when I do that, t is minus 1 by 2, right? And that is what we can see from this plot as well, right? So the rule that you were referring to was statement that I made. Suppose you have this function x of 2t minus 2, right? You cannot scale this function by 2 and then shift this function by 2. The shift should be the shift in the time. Okay, so that is why we were taking this common. Why is it? Okay, see, the shift should be in time. Suppose I give you x of bt plus a, right? What is the shift in time for this general signal? I'm taking a general case. Are you able to follow?
Yes, sir. Yes, sir.
Yeah. What is the shift?
Sir, it seems like shift is A,
Okay.
but it is not in T. It is scaled. First is scaled by B, then.
Yeah. Whenever there is a scaling operation, you need to be careful. The idea is the shift is in T, not in the argument, right? For that, what would you do? You would express this. You'll take out B common and then you can write it as T plus A by B,
Okay, sir.
right? See, is this clear now?
Okay, okay, sir.
Okay. You will anyway get access to the recordings as well. You can go over through it again if you have any doubt. Okay. I'm sure it will be clear. Okay. Is that it? Any other doubt or should we
Sir,
end the session?
we have not brought the mathematical form similar to this in the last few questions, sir. And there,
Mathematical?
sir, we are taking here like we are taking here a common B, and
Yeah.
the factor is coming into a fraction. But in the last few questions, sir, there is
Okay.
x
Which
3n
question?
plus 3.
Let's go through them. Which question? Which question? This question? No,
Sir, I
this
think
one. If this is the case, this is already in that form, right?
no, no, sir. और थोड़ा और नीचे
This is
जाइए सर.
already. Let's see the examples that I had taken where you can consider them to be special cases, right? You did not need to take out the coefficient because the idea is when scaling and shifting occur simultaneously, you need to exercise a caution, right? Especially if you are taking shifting operation first, you need to take that common, right? In fact, this,
Sir, one example where there was a ramp function with a square function.
wait, a ramp function with a square function. Are you talking
The,
about today's session?
yes, sir, yes, sir. In those
Okay,
questions were towards the end, sir.
towards the end. This one,
Yes, 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 yes.
ramp. Okay,
Look, uh,
okay. Even this one,
sir, here 3 is not, we have not taken, sir. in the answer,
Yeah,
sir. That's
agreed. But see, what we did was, wait, 3t plus 1. Let's perform a sanity check first, okay? A sanity check would be that this 3t plus 1 would be 0 at, help me out, okay? This 3t plus 1, when this would be 3, this would be 3 when this t would be this 2 by 3, right? And that is indeed the case, right? So let's see what if we do the other way around. Let me use some gray color. I'll think over this, okay? I'll let you know. Fine.
okay, sir. Okay,
Probably
sir.
in the next tutorial session, or you can drop me an email. You will have access to these slides. You can drop me an email and I'll address this doubt. It was a good question, actually. Yeah, that was all from my side. Any other doubts apart from this one?
No, sir.
Okay, thank you. I'll be
Okay, sir.
ending the meeting.